This shear is a very, very big hachodesh for ever we're going to learn a Rambam from now till the end. And there's some mathematics, but some things that even if you don't want to know the math, you need to understand the fundamental of what's happening here. So the calculations up till now were all based on flat trigonometry. It means two-dimensional, just a flat surface with lines. You figure out the angles, the sides, and so on. Now we're entering a new area. It's called spherical trigonometry. The idea of this is, take a look at this left side picture. So we have, it's very good, very useful. You should have a globe. You can buy for 99 cents a globe, or take a big globe. And imagine you take a marker that you can erase, or you can put a piece of tape maybe. And from the North Pole, go down one of the longitude lines. Now you can see if a globe has lines going longitude, that's like going from one pole to the next pole. So just imagine you have a line going from the North Pole till New York City. Now New York City, we know, has a latitude. It's above the equator, 40 degrees. So that means this line here is 60. It's 50. Because it's a complement of 90 degrees. So this is 50 degrees. Then take another and draw the second one from the North Pole till, let's make it till Texas. Till the southern tip of Texas. And the last one will be a line that will connect these two. So now we have created something that's called a spherical triangle. The definition of the spherical triangle is all these three angles must be part of something that's called a great circle. Means this line, if you continue it, it will go all the way to the South Pole. This line also. This is a little bit tricky. The line here, you can also imagine, it connects these two dots, this one and this one. You can imagine that this could be, at least in theory, part of a big circle. Big circle means a circle that has the full circumference of the sphere. You know that there are small circles also. You can look on your globe, you'll see small circles, smaller circles. So these small circles cannot constitute parts of a spherical sphere. A spherical triangle. Spherical triangle, because then everything gets messed up and all the rules don't work. So we must have, in order to, all these rules that are going to work for this mathematics of a spherical triangle, the only way it works if all three sides are parts of a big circle. Now, here you can see the way the mathematicians label it. So there's the interesting thing here. This is a thing that takes time, and it's worthwhile investing a lot of time because it's very fundamental, very scientific. There are 6 angles that are involved in every spherical triangle. Let's see how. First we'll go the easy ones. You see there is a small a here, a small b, and a small c. So let's understand. These angles are, B is very easy to understand what it is. it's how much you go down from the pole. As we said, now if you go to New York, it will be 50. And this small c is, let's assume we're going from the pole till Washington State, because it's less than, b is bigger, so that's c. So let's say b is 50, c is only 40. It's higher to the pole. Okay, the other angle is an angle that's not obvious, and we have to use mathematics to calculate what is a small a. There's a formula for it. Let's assume we know b. As I said, let's assume that b is 50. Let's assume c is 40. Another angle is the big A. What's the big A? What does that define? That defines the difference in longitude from C to B. That means, let's assume New York is, the longitude of New York is 70, and Washington is 130 west of the Greenwich. So the difference A would be the difference of 70 and 130. That is 60 degrees. So again, so we have three angles we know here. We have this wide angle, big A. We have small b and small c. However, there's another three angles that are unknown. That is C, big B, and small a. Try to imagine that you take this point C and you put it on the pole, and you flip it over. You let B hang down and A hang down. C will touch the pole. What will be angle C? Just like we know angle A is 60, right? Because it's 70 to 130. So C also has a certain angle. Same question you can ask a B. Imagine you'll flip it this way. You'll turn this whole thing in a way that B will touch the pole. Now you'll have these two things coming down from the pole, BA and BC. What will be the difference in longitude? So that's called the B angle. So, and last but not least, you can ask the question, if C or B will be on the top, so A is gonna hang down, how much degrees will A be? The small a, I mean the small a. So we have here three knowns and three unknowns. The rule is, very, very important rule. If you know three angles, the other three can be found by certain rules, formulas, and I'll just show you the formulas. If you don't understand it, it's okay. Just want you to get the concept that from known three, you know the other three. Any three, you can know small a, small b, small c, big B, big A, big C. Any three are known, there's formulas to get the other three. It's a very interesting fact discovered by the Kadmonim. And almost everything from now to the end of the Rambam will evolve around this principle of finding through three known angles, finding the other unknown. This will be the pivot. Everything turns on this. We get the details of it. This is the Yesoid. The Yesoid is we're trying to find unknowns through spherical trigonometry. Okay, let me just show you. This is the, you don't have to understand it, you just look at it. For example, you don't know what a small a is. You know, big A, small c, small b. You know these three. You can find small a. You don't know what small b is, but you know big B, small a, small c. Same thing, this. And then there's other relationships. Sine A over sine small a is the same as sine B over sine small b. So let's say you know big B and small b and a, to find the ratio has to be equal. This is for somebody that knows how to do math. He knows that if you know a ratio and you know this top part, you can know the bottom part. Next, here's another case. You know two of the big angles, the wide ones, and then one of the small ones, A and B and C. You can find big A. Other ones are similar, just using the same thing. Different, just all these three are the same. Here comes interesting stuff. Here is a case where we know we have to know for this. Look, you know C, big A, big C, and small a and small b. It looks very confusing, but honestly, when we'll go through all the stuff, we'll see exactly when we use each formula. And all these formulas are useful. You see here, you see, this is the way the convention works is the big B is here and the small b is here. The big A is here, small a is here. The big C is here, we'll see. Remember, all these six may be different angles. They have a certain relationship, but they're not the same. As we said, you know, you can figure it out. We'll get to some examples later. They're related, but they're definitely not the same. And there's a formula. This angle is always a little bit bigger than this one. That's the mean. That's why it's called big. So okay, I guess we'll stop here. This is the introduction for spherical trigonometry.